we've got a lot of theorems. We got to just keep writing them and remembering them, because when are we going to have to remember them? What type of problem always makes you remember what they are?
Proofs.
Proofs. Perla's least favorite type of problem. Missy, if you're going to be a lawyer someday, you better get used to it. All right, so this theorem, but the nice thing about the theorems, guys, is that the name of the theorem always tells you what you're talking about. So you don't have to remember too much. You just basically have to remember if it's a theorem or if it's a postulate. So the SAS triangle congruence theorem is the one that tells you that two sides and the included angle have to be congruent. So let me know, does anyone still need a second to write this down?
No.
You guys are all good?
Or at least I'm good.
Anybody need a second? Going once. Going twice.
Wait, miss, I have a question.
Yes.
So as long as like the sides are on the sides and the angles in the middle, they're congruent?
Yeah.
Alright.
It has to be the angle in the middle. So that leads me to this problem. So take a look at this problem. Let's figure out if these are congruent using SAS. So I have a side. I have a side. I have another side, which matches with this one. But what's wrong with the angle in between?
They don't match.
They don't match, exactly. So this would not be congruent because, so triangle ABC is not congruent to triangle
EDF.
You're
Wait,
right.
D.
No, D.
DEF.
DEF, yeah, DEF is not congruent because SAS does not apply. So since we can't use SAS, they're not congruent. It would have to be the same exact angle.
Would the
in
same
between.
thing go for SSS?
The same thing will go for SSS, yeah, and we'll talk about that in a little while. Okay, so let's do a problem. So I want to know if these triangles are congruent, and we're going to see if we can use SAS to prove that point. So looking at number 2, I'm going to start playing a little game of match, okay? So I have
You
QR.
can prove
Okay.
You can prove the number 2 SAS.
Yeah, so tell me why. So I have angle.
So it shows you that P and R are the same angles because it has the circle
thing
right there, and then it already shows one of the sides. All you have to do is find out the other one, and that's the same length of the other side because these two are the same.
What's that theorem called?
Reflexive property.
Reflexive property, exactly. So exactly, just like Daniel said. So we have a side, an angle, and the side. And you have to just make sure that the angle is in the middle. And in this case, it is. So we have SAS. So it's very important. The biggest thing to remember is that the angle that you're looking at has to be located in between. So now take a look at number 3 and see if you can prove angle 3 is congruent using SAS.
Yes.
You agree?
Yep.
Perla, do you agree? Yes? Okay. What is my first S?
30 millimeters.
The 30 and the 30. Okay, so that's S. What's the angle in between?
BC or CB.
Remember, the angle has 3 letters in its name.
Wait.
Miss, is it BCA?
BC.
Oh no, B.
BCA would be this one.
Ah, so BAC.
BAC would be this one.
Oh. Then it's the other way around. Never
So
mind.
what is it?
We go Tyrone.
I'm kind of confused.
BDC, Janelli says. BDC would be this one.
Oh, and the other one will be BAC.
Yeah, but do we
So
know
is
anything
it
about those?
CBD?
CBD? Yeah, that's one of them. There you
And
go.
then CBA.
And CBA. There you go. So remember that the vertex has to be the middle letter. So those are my,
okay, I get it.
yeah, so that's the angle. So there you go. And then what's the other side of this SAS? So far I have one side, one angle, and what's my third side?
The other 30 mil. Wait. Can you repeat the question?
I have one side, I have one angle. I still need one more side in order to prove SAS. So which is the third side or the second side that is congruent?
CAB or wait.
I need a side.
AC and CD.
AC and CD. Does it tell me anything about this being congruent?
Oh.
Is it BC?
Oh, yeah.
It's
Is it-
BC, yeah. Because what is that property called?
Oh, the reflexive property.
Reflexive property, exactly. Hold up, everything got
It
deleted.
was confusing me for a second.
Wait, it's reflective or reflexive?
Reflexive with an X.
Oh.
There we go. So this is congruent to itself. So there you go. You have side, angle, side. And one thing I want to do is I have two triangles here. I'm kind of going to like separate them for a second, just to show you guys something. So pretend I separated them. I kind of took them apart. And I had A, B, C. And then the other one would be C, B.
A.
No.
Oh, D.
D. Okay. So I'm splitting them apart. And I'm just going to put all the markings down. So I know this one is congruent to this one. I know that BC is congruent to BC, to itself. And then I know that angle B is congruent to the other angle B. So sometimes it's a little easier to visualize it when you kind of pull them apart. But notice that I have side, angle, side. You can now see it very, very clearly that you have side, angle, side on both triangles. So if it's a little confusing sometimes to visualize it, pulling those triangles apart might be super, super helpful. I can do it with example 2 as well. So on triangle PQR, so this is PQR, and then I can separate it from triangle RSP. So now once they're separated, I can again label them. So I know PR is congruent to PR. I know angle R, oops, hold on. Angle R, here it is congruent to angle P. And I know that QR is congruent to PS. So again, you can clearly see side, angle, side. Two sides and the angle in between. All right, so any questions on SAS?
No.
Awesome. All right, so then there's SSS, okay? So SSS is exactly what it sounds like. If you can prove that the three sides are congruent, you can prove that both triangles are congruent. So in this case, let's play match. I have 17 or 1.7 and 1.7. Then I have
2.3 and 2.3.
2.3 and 2.3.
2.4 and 2.4.
2.4 and 2.4. So triangle
Side.
ABC is congruent to What are the matching values on the other triangle? So
Would
A,
it
B,
be
C.
D,
DEF.
E, F?
Mm-hmm. Because it matches the criteria for the SSS triangle congruence theorem. All right. So those are almost all the theorems. There's 2 more that we'll hit next week. But so far we've done, let's list them all. We've done CPCTC, which is everything matches. Everything must match. Then we have ASA, which is 2 angles and the included side.
Then you have SAS.
SAS.
2 sides plus the included angle.
Mm-hmm.
And then you have SSS, which is all sides.
Exactly. And like I said, there's 2 more coming our way. But for this week, we're just going to focus on these 4.
Would it be AAA?
No, actually. AAA is not one of them.
Oh, no.
All right. And we'll talk about why. All right. So now let's do another problem. This one's a little bit hard to, it was hard to see like clearly what they're labeling. So I'm going to draw it again, but a little bit neater. So give me just a moment to redraw it. Something like that.
Miss
And so-
Lopez,
Yes.
I have a quick question.
Yes.
So for the SSS theorem,
Mm-hmm.
if like let's say all the sides are equal, right?
Mm-hmm.
What if the angles are not equal? Would that be possible or?
So the reason that SSS works is because if all the sides are equal, all the angles have to also be equal. So that's why I can prove that they're congruent just by looking at the side measurements.
Okay, thank you.
You're welcome. Alrighty, so here we go. So let's play a game of match. I kind of tried to label it a little bit more clearly because it was hard to tell which number went with which side. So let me now label all the letters. Okay. All right, so play a game of match. I've got my 20 goes with my 20.
24 with your 24.
24 with my 24.
And 12 with 12.
And 12 goes with 12. So are we good here? Do I have SSS?
Yes.
Yeah, I've definitely got SSS. So again, it's just playing a game of match. Can anyone tell me how I got, what transformation could get me from DEH to FGH? What type of transformation brings
Wait,
one
can you
triangle?
outline DEH?
Rotation.
Yeah, Jalen's got it. And yes, I'll highlight. So from the red triangle to the, I'll make it blue triangle.
All right, yeah, a rotation.
Yeah,
Big
Jalen is
plate.
correct.
180 degrees rotation.
180 degrees rotation around where? Which point would be the center of rotation?
H.
H.
Yeah, H right here. So he kind of goes whoop like that. Good job, guys. See, it all comes together.
Big
Big
brain.
brain ladies.
Big brain. All right, let's do another couple ones using SSS. So this should be number 5, my bad. Number 5 should be pretty easy. Go ahead and let me know. Does number 5 match up?
Yes.
You sure?
Wait.
No.
No, it doesn't. No, it doesn't. No, it doesn't. No, it doesn't.
Why not? Which one doesn't
Because
match?
everything matches up except the 28 and the 32. I didn't see that.
You're right. Okay, so those
Why
do not
not?
match. So unfortunately, we can't say that these are congruent. So I would say M and P
Is not
not
congruent
congruent
to RQS or
Miss
to,
Lopez.
yes.
But if N and R,
Mhm.
like the angles are equal, then they would be congruent, right? Because of the side angle side.
If the angle, yeah. So if this angle, which one? Which one would have to be?
N and R?
N and R?
Yeah.
Well, remember, it has to be SAS with A in between.
Oh,
That
yeah.
one in between?
No, then
No.
M.
It would be
M.
Which one is in between the red
P.
side and the blue side?
P.
Yeah, P. It would have to be this angle and this angle.
And S.
Right. So if that was true, then yes, they would be congruent. But since we know that the third side doesn't match up, we know they're not congruent. So these do not pass the SSS test. Okay, so for this, because SSS does not apply. What about in 6?
Yes.
Yes, yes it is.
Okay, so I've got how many? I've got one matching side over here.
And then you have another one.
I've got another one down here. And what's my third one? And how do I know?
The reflexive property.
The reflexive, which is GJ or JG.
GJ. Yeah, GJ is congruent to itself. So I've got 3 sides. So can somebody give me my congruence statement?
Congruence statement.
K. Wait, or is it
You can
K,
pick-
G, J, or?
As long as it matches. So
It's
whatever order you want.
congruent to G. Wait, no. Is congruent to LJ. Wait, LGJ.
There you go. Good.
It
By
really is.
the SSS congruence theorem. We always have to have a reason. Okay, so you can't just tell me they are. You have to tell me how you know they are congruent. All right. Okay, so we've gone through everything, all of those statements that we're doing this week. So let's do a quick summary of which ones they are. So in this case, which of the following are reasons that justify why the triangles are congruent? So which of these theorems can I use for this example? I'm going to put a poll.
Sorry. What does
SAS.
converse mean?
Refuse.
C.
Let me explain converse in a second, okay?
Okay.
So I've got A, B, C, D, and E. Oh, I don't know if my poll has that many
Wait, we're doing
letters.
a poll?
Yes, hold on.
Okay, good. Nobody hears my answer.
All right, go ahead. This one has an extra letter. Just ignore the F.
Wait, this is multiple choice, right?
It's just one.
Oh.
Just one answer.
And why does it say multiple choice?
Because I had it set up that way by accident and I didn't feel like changing it because that takes a long time.
And also on the slide it
Slow
says
being
select all.
lazy.
Miss Lopez is not being lazy. Miss Lopez is being efficient.
Ms.
Well,
Lopez.
I already said the answer, so.
Ms. Lopez.
Yes.
For the SAS, the angle has to be between both sides, right?
Correct.
And for the SSA, it has to be like side. Okay, yeah, never mind.
It tells you the order, yeah. And we haven't gotten to SSA, so you can kind of think, okay, maybe that's not the right answer. Okay, one more second. Submit whatever you think it might be. Pick one answer. All right. I'll pause it there. Oops. Okay, so here are my results so far. B was winning, but C also came up pretty often. And I know I said pick one answer. And I know that it says select all that apply. I just wanted to see which ones you guys noticed first. Because yeah, there actually is more than one answer. More than one correct answer. So I'm going to skip A because we haven't really learned SSA yet. We'll learn that next week. But
It's
Side angle.
Side angle. Yeah, we haven't really talked about that yet. So like I said, we're not going to really use it. But we've got SAS. So let's check. So if I have SAS, I would need two sides and the angle in between. So if that's the case, can anyone tell me which sides and which angle I would be looking at?
I don't think it's B, because I just actually
Well, let's
I
play a game
disagree
of
with
match.
Tyrone.
Let's play a game of match. So Perla, what do you think?
You see the little AB is a side,
That's one.
and
A
then
is an angle
A is an angle, and
and
then
AC is a
is the
side.
side.
Right. So I've got two sides that match, and I have the angle that is in between them. So I definitely have SAS.
Oh wait, I got confused because like one of the sides had 3 slashes and one only had 1. That was the one that confused me.
So you had to match whichever one has 3 goes with the one that has 3. The one that has 1 goes with the one that has 1.
Ms. Lopez,
Mm-hmm.
wouldn't this be the SSS too? Because you can't just get from 1 to 3, or can you just get from 1 to 3 tick marks?
So I can't assume. It doesn't tell me anything about BC or FE. I cannot assume that they're congruent.
Okay. So they can't just like skip from 1 tick mark to 3.
Right. Yeah, they did that. I don't really know why they did that, but it's fine. All right. What about ASA? Do I have ASA?
No.
Angle, side, angle. And the side has to be in between.
Oh wait, I didn't see
The
the
angle
C.
is C, the side is CA or AC, and then the other angle is A.
Good. So I have two angles. A and C matches with D and F. And then I have the side located in between them. Okay, so there's my ASA. Now with ASA, you had to be a little bit careful because does this prove ASA?
No.
No, it has to be two angles and the side in between. Okay. All right. And so, okay, so now let's talk about this CPCT versus the converse of CPCT. So CPCTC, let me like write it out. Congruent parts, or no, sorry, I always mess those up. Corresponding part.
Parts of corresponding.
Of congruent.
Triangles.
Are congruent. So this one's
Shouldn't
saying
it be CPOCTAC?
Okay, all right. So here's the difference. This is saying if two triangles are congruent, all of their parts that are corresponding are congruent. The converse of that is saying it backwards. So the converse would say, this would say, if all corresponding parts are congruent, the triangles are congruent. So one is saying if the triangles are congruent, the parts are congruent. The other one's saying if the parts are congruent, the triangles are congruent. So it's they're saying the same thing, but in one direction and then in the opposite direction. So the one that we can use to prove that the two triangles are congruent would be the converse of CPCTC. And I haven't been saying that because I wanted to get to this point and explain it. But in a proof, if you see that all of the parts of the triangles are congruent, you would say the converse of CPCTC.
So it's the same thing?
It's the same thing, but they're in different directions. So remember, CPCTC is you have congruent triangles. So that tells me I have congruent parts. The converse says if you have congruent parts, you have congruent triangles. So they're saying the same thing, but in opposite directions.
Miss, so the parts are like the angles?
Yeah, all the angles match, all the sides match. So CPCTC, just the original one, would be like if I was like, oh, wow, look at these triangles. They are congruent. Therefore, I can say that angle A matches angle D, angle C matches angle F, angle B matches angle E. All of the parts are congruent. The converse would be if I was like, oh my goodness, look at all of these parts. They are all congruent to each other. A is congruent to D, C is congruent to F, B is congruent to E, yada, yada, yada. Therefore, the triangles are congruent.
I understand now. Thank you.
You're welcome. All right, so let's do a couple more summary problems. Okay. This is a little bit wordy, but remember that on the tests, sometimes they love to throw problems out there that have no graph, no diagram, no shapes, nothing, just a bunch of words, and we have to understand what they mean. So let's just do each one at a time. So we need to determine whether the given information is sufficient, is enough to guarantee that the two triangles are congruent. So we're going to read each scenario, and I need to know if I have enough information to tell me if it's congruent or not. So we ready? Let's start with A. Can I have Alejandro read A?
The triangles have 3 pairs of congruent corresponding angles.
Is this enough information? Sufficient or not sufficient?
Me?
Anyone?
Yes.
Yes?
Wait.
Not sufficient.
Not sufficient. Jalen,
No.
why do you say no?
Cause I forgot already. Hold up.
Miss, can I go?
Sure.
Because the angles can be the same, but in order for them to be like congruent, their side, like the length of their sides have to be the same too.
Right. So this is telling us basically that you have A. But is there anything at all that I've ever said that is AAA? No. Because remember, there's only 3 options we know about so far. SSS, SAS, ASA, and then obviously CPCTC. All right.
And
what
SSA.
about for B? Can I have Eric read B?
Miss, how could you betray me?
Sorry.
You read a lot. You need to take a break.
I like to read.
Let's go ahead. Let's let Eric read. Go ahead, Eric.
The triangle have 3 pairs of congruent corresponding sides.
All right. Is this enough or not enough?
I think it's enough.
It's enough. So this one's telling us which possible combination is this one?
Oh, SSS.
Yeah, this one's SSS, and that is allowed. That's good. That's sufficient.
Can I read?
Okay. Yes, Jalen, go ahead.
I call reading after.
Okay.
The triangle have 2 pairs of congruent corresponding sides and one pair of congruent corresponding angles.
Okay, is this enough?
No.
No, why not?
Because that's SSA.
Well, here's the thing. Does it tell you where the angle is located?
No, because the angle always has to be in the middle.
Has to be in the middle. So what word should we be looking for here that is not there?
SAS.
But what key word is it missing? What's the missing piece of information?
Midpoint? No, right. Never mind.
So right now, all we know is that there's 2 pairs of corresponding sides. So we have S and we have S, and then 1 pair of corresponding angles. So I have SSA, but do I know which order those 3 letters go in?
No.
telling us anything about where they're located?
Nope.
No, and they have to tell us that the angle has to
Included.
be included. Exactly. So this is missing the word
Included.
included. So this is not enough. All right, Tyrone, go ahead. D.
The triangles have 2 pairs of congruent corresponding angles and 1 pair of congruent corresponding sides.
So what about here?
Wouldn't it be like the same thing?
Yeah, what it's also missing
Included.
included. Not sufficient. All right. Who would like to read number E, letter E?
2 angles in the included side of one triangle are congruent to 2 angles in the included side of the other triangle.
What do we think? Yes or no?
Yes.
What's
Yes.
this? Which
Because it
scenario
has
is this one?
included.
That is ASA.
ASA.
Good. ASA.
ASA.
ASA is all good.
It's 1 letter off of NASA. Oh my
All
god.
right. And then for the last one, who would like to read my last
2
one?
sides are in. Look. 2 sides and the included angle of one triangle are congruent to 2 sides and the included angle of the other triangle.
Good. And this one would be?
Sufficient.
Good.
What if the triangles are connected?
This would be which of the scenarios?
SAS.
SAS. Good.
SAS.
Even
SAS.
UCPCT blah blah blah.
All right. So there you go. There's all of those. That's the keywords are very important, and reading carefully is very important. Okay. Here's
People have
an
typed in the
interesting
chat
one.
more than 100 times.
Yeah, you guys are going wild in there. All right, so here's another problem. This time my triangles are located on the graph. So even though it's not labeled, what can I figure out?
The side, the angle, and the other side.
Okay, so how can
They're congruent.
Okay, so we know that they're congruent. Okay, that's good. But
you could definitely figure out the sides and the angles. You can figure out the sides and the angles.
Okay,
the angle
so
is a 90-degree angle.
Let's start with the
Can I
easy
do
ones.
B?
Let's start with the easy thing to figure out. What's one thing I can easily figure out?
The angle.
The angle. And which angle is obvious?
The right angle.
Yeah, the right angle. So I know I have one angle. Now I also need these side measurements. So go ahead and count and see if these sides match up.
Yes, they do.
Yeah. How much does it measure?
6.
6 on both?
Yes.
Yes.
Good.
The
So
line
this is
separates
6.
it, so it's easy.
That's 6. And then what about the other
6.
side?
2.
2.
Oh wait, that's fine.
Yeah. So I know they're congruent using which theorem is this?
A side
SAS.
angle side.
Side
SAS.
angle
SAS.
side. Good. Question.
No.
Could
B.
I figure out SSS? Could I use SSS?
Yeah.
Yes.
How would I do that?
You have to locate the other side.
Yeah, right.
So I would need to find the length of my third side, and I can do that
Is this
using
7?
what Perla.
Pythagorean theorem.
Pythagorean theorem.
You see, Miss, I'm smart.
He always be
I'm
coming
smart.
back though.
So let's do that real quick.
Pythagorean theorem.
6 squared plus 2 squared equals c squared. 6 squared equals 36. 2 squared equals 4 equals c squared. 36 plus 4 equals 40 equals 6 squared. And then I don't know what.
For those of us following at home, what Perla just filled in.
Okay, so basically it's just 4
Mm-hmm.
plus
36.
36
Oh wait, I was right.
equals 40.
Mm-hmm. And how do I get C all alone?
Square root.
No, not divide. Wait, I think it's divide.
Nope. What's that called?
Square root.
Square root.
Square root.
All right. So C is the square root of 40. If I put that in a calculator, would I get a nice whole
No,
number?
it would be like a dumb decimal.
Be a decimal. So I'm going to leave this as
6.3245553.
yeah, it would be a whole long decimal number. So
Can I do B?
Pause there. Okay, let me finish. So C, I'm just going to leave it as the square root of 40 because otherwise I'd have a long decimal that would not help us out. So my point is you could use SAS and you could also use
SSS.
SSS.
I don't know.
All right. B, can you read B for us, Tyrone?
Describe a sequence of rigid motions to map the top triangle onto the bottom triangle to confirm that they are congruent rotation.
Rotation, okay. What type of rotation?
180.
Perfect. This is a 180-degree rotation around the
Origin?
yeah.
So everyone's gonna ignore that we fell off my chair
Yes.
and screamed in pain.
Or
Completely.
Daniel. I don't have a Band-Aid.
Alrighty. Questions, comments, concerns with how we figured anything out in this? This was a really good problem because it mixes everything together. So do I have any questions?
Smart
Look
class.
at everything. Check out. In this one problem, we did like 3 things. We used our theorems. We had to do Pythagorean theorem, aka the distance formula. And we used rigid motion transformations. Okay, so all those concepts, they always come together and they never go away. So any final questions? Yeah,
I have a question.
Yes, Daniel, is it appropriate
Who
to
wants
this
to play
class?
Among Us after 8th period?
Okay. All right, so now we can move on to Perla's favorite part of the day.
No! I hate this!
Too bad. I'm muting him. All right, y'all. Here's what I want you guys to do. Here's what I want you guys to do. I want you to, in your notebooks, copy down the statement and reason chart. So just the chart. Copy down this chart and be ready to start filling it in.
No!
Daniel. All right, take a minute, guys. Copy down that chart. Leave enough spaces.
Dying.
1, 2, 3, 4, 5, 6 blanks in that chart.
Can I do number 1?
When we get there, yes, but I'm giving you guys a couple minutes to just copy it down.
Miss, that's not fair that Tyrone always gets to do the one that says given.
Hello, stop ruining my spot.
He just likes to think he's smart.
Is that a I forgot what the word was.
What do you call that? A drag?
I don't know. And what do you mean I think I'm smart? I'm smart because if I wasn't smart, I wouldn't be here.
I know, I'm just pulling your leg.
My poor feelings. Oh my God.
All right, be ready to start writing down. Once you've copied down the table, just maybe start thinking about what your answer might be, thinking about what you can already copy down without doing any work. Start remembering all of those theorems that we love.
Wait, are we doing the first one?
I'm sorry?
What would be the given?
AC is congruent to AE given.
Nope, that's what we're supposed to
read carefully. Read carefully. What does the problem say?
A, B, C, D, E, F.
Is what?
A hexagon.
A regular hexagon.
A regular hexagon. So this is what it's giving you.
Oh, okay.
So what's my first statement?
Polygon ABCDEF is a regular hexagon.
Good.
Given.
Ms. Lopez, can this go like in in any order? Like
no, things have to go in a very specific order. That's kind of the point. In proofs, one thing has to lead to the next thing. It has to go in an order that makes sense. So you can't just start like putting things randomly.
So if I wanted to say like, let's say an example, AEF is a congruent triangle.
Mm-hmm.
Can I say that, or do I
you have to get there slowly and carefully, because before you can say that it's congruent, you have to prove that the sides are congruent, the angle is congruent, and whatever else you need. It's a good question. All right, so I have my first thing. I can also fill in my last statement. And Janelle's, do you want to give us that one?
Okay.
What's the last statement?
The last one is
Go ahead.
AC is congruent to AE.
Good. And we don't have a reason yet because we're going to have to get to that reason. But for now, we can at least write that part down.
Ms. Lopez, Ms. Brown says hi.
Hi, Ms. Brown. All right. So here we go. Remember what I said yesterday. Anytime that I put down a keyword, I'm going to need to give the definition in the next step. So what keyword have I written down in the first step?
Polygon A, B, C, D, F is regular hexagon.
Okay, so regular hexagon, right?
Oh, regular hexagon.
That's my keyword. So I know I'm going to have to define it. So let's think about it. What is a regular hexagon? We've seen it before. What does the word regular mean?
Normal.
Okay, be more specific.
I forgot.
Anyone can jump in.
I can't jump. I'm sitting in a chair.
So it's got 6 sides because it's a hexagon. That's true. And what's true about all of those sides?
They're equal.
Exactly. They are equal. So every single side is congruent to itself. Okay? To all the other sides. But we don't care about every single side. We're trying to prove that these triangles are congruent to each other. So I've got a couple of triangles in here, right? So, Daniel, I've got a couple triangles here, so I'm going to highlight them just so that we can keep track of them.
ABC and AFE.
Miss Lopez, there's no name for like when shapes, like all sides of a shape is congruent, like, no, right?
What do you mean?
Assume, like for this hexagon of a...
The keyword?
Right.
The keyword is regular.
Oh, okay.
So if I have a regular hexagon, that means all 6 sides are equal, all 6 angles are equal. If I have a regular octagon, all 8 sides are equal, all 8 angles are equal.
AC is
equal.
Okay. So right now, all I know is that it's a regular hexagon. But I know what the definition of a regular hexagon is. So can anyone give me a congruent statement that I can write?
Okay, so this is where I stopped talking.
Everything is equal, yes. So give me, since I'm interested in these 2 triangles specifically, what congruent statement might help me out?
All sides are equal?
But I don't care about all the sides. I only care about these 2 triangles. So let's use the sides in these triangles.
SSS.
SSS or S. Oh no, SAS. AAA. SSS. SSS.
That's a reason, not a statement. Somebody give me a statement. Give me 2 sides that are congruent to each other.
2
Side
sides.
AB is congruent to side EF.
So AB, you said AB, right?
Yeah.
All right, so AB is congruent to, what did you say?
EF.
EF, very good.
If you remove C, if you remove, I forgot what it's called, if you remove the polygon CDEA and move it to the right, and you close the polygons A, B, C, and AFE,
It's a fish.
you'll see that they're equal.
Okay, but it takes a lot of work to get to that point. We can't just jump to that conclusion. We have to go.
How about we say kill CDEA?
Yep.
And
I love your imagination, Daniel, but that's not going to get you an A on your tests. All right, so we're moving. Remember, it's got to go in order. So I know that AB is congruent to EF, just like Tyrone told us. But what is my reason? How do I know that?
Because
of the line. Wait, no. Wait.
I drew those lines in.
The congruence statement. Wait, no.
It is
Because of A or no.
Wait a minute.
How do I know that those two sides are equal to each other?
Because
they're the same distance from DNA.
SSS or
Nope, you guys are overthinking it, guys. Remember, it's easier than you think.
A.
Because they're congruent.
Yeah, but why?
ASA. Yeah.
Because the sides of the hexagon are congruent.
Okay, and so what does that boil down to?
The congruence statement.
We know that all of those sides are congruent. We know that all 6 sides are the same. How do I know that? Because this is what type of hexagon?
Regular hexagon.
Regular hexagon. So guess what goes in number 2?
The regular hexagon. Definition of a regular hexagon.
Yep.
What's with that horrible echo?
No, because Kayla had her mic on when I had my mic on.
Okay. So again, what did I do in the previous step? I said the words regular hexagon. What do I do in the next step? I define the words regular hexagon.
For me, in the second one, it says it looks like a regular instead of regular.
It kind of does, though.
I'm so sorry. All right, moving on. I know now I have 2 pairs of sides that are equal. I should probably get another 2 pairs. So I know somebody was going to say
BCFE.
BC and
BCV.
And F. Be careful. BC.
EF.
And we already did EF. So here I have to do
AF.
AF. And what's the reason again?
Definition of a regular
Same exact reason.
Definition of a regular hexagon.
Oh God, I just there we go.
Okay. Definition of a regular hexagon.
Definition of it.
Okay.
And then we can do CA and AE.
So now we know, okay, because what are we trying to figure out at the end? We're trying to figure out.
Prove that AC is congruent to AE.
So we want to prove that this side right here is congruent to this side right there. Okay, we don't know yet. We haven't proven it yet.
It is.
Well, okay. I know it is, but we haven't proven it. That's what I'm trying to tell you. You're jumping to conclusions, but we have to take steps to get there. So before I can get there,
we have proved, Ms. Lopez, we have proven it because we have the two sides that we need. All we need is.
So just
Daniel, take a chill pill.
Just because those 2 sides of the triangle are congruent means the third one is congruent?
No. That's not how it works.
We technically already know that the angle B is angle F because the 2 sides.
Oh, say that again, Daniel. You just struck it perfectly. Can you say that again?
Angle B is angle F. Angle B is angle F.
Angle B is congruent to.
Can you stop shouting?
Angle F.
No.
So, Daniel, you said it perfectly. Daniel said it perfectly. The next step is to show that angle B is congruent to
Angle F.
And since we already
Again,
know
what is
that, there's
I
only
know.
one side left.
I know.
Side
I know. Okay, Daniel said this. Now, what's the reason? How do I know that those two are equal, congruent?
Definition of.
Yep.
Because we have the two sides already.
Not because we have the sides, but because we know that this is a regular.
We have the sides.
Hexagon, and regular hexagons have all the same sides and all the same angles.
Like if you folded it in on itself, it would be a line.
Yeah. Okay. So now I'm so close, guys. I'm so close. So far,
know that they're equal.
So far, this is all I have. Right? So far, this is all I have. However, what congruence statement do I have? What congruence statement or congruence theorem can I use now?
I forgot his name.
Think back to today's lesson. What congruence theorem about triangles do I have here?
SAS. SAS.
SAS. Good. I have S. I have A. And I have S. I have SAS. So now I can say that the two triangles, so triangle ABC is congruent to triangle. Somebody match my statement. ABC is congruent to?
ABC is congruent to EFA.
Good. EFA. And the reason is I used SAS congruence theorem.
Miss, you see, if we didn't have you, we wouldn't have been able to do this ourselves.
I'm not telling you have to know how to do this yourselves, guys. Right now, I don't expect you. Right now, I don't expect you to. But we have to start figuring it out as we go. Okay, we get it harder and harder each time until we figure it out. Finally, now that I know that these triangles are congruent, I can say that AE is congruent to AC. But what did I just use to show that AE is congruent to AC? Since I know the triangles are congruent, now I can tell you.
Wait. Is it also given?
Nope.
No.
It's proven.
Yeah, but how did I prove it? How do I know that those are congruent to each other?
Side.
Close, but not quite. Yeah, Emily's got it.
Side angle.
CPOCTAC.
CPCTC because remember what I did. Once you know the triangles are congruent, which we did.
Everything is congruent.
You know that everything is congruent using CPCTC. Okay, so good job, Emily. You got the last one. Nice job. So again, I'm not saying that you guys have to know how to do all of this perfectly all by yourselves right now. You don't. You shouldn't, because it's hard. It's not easy. But as we do more and more and more, you guys are going to pick up on all those patterns, understand how to do it, and it's going to get easier and easier. But you just kind of have to struggle for now. So we're going to do one more. Janelle's, you can go to the bathroom. I know you asked me before. This is going to be our last one, though, guys. Okay, this is it. I promise. So let's work through it again together. So start by just go ahead and copy down the statement and reason chart. And just remember, all of those reasons in the reason column, it's going to be the definition of blah, 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 the blah, blah, blah theorem, the blah, blah, blah postulate. It's always going to be a definition, a theorem, or a postulate. So when you're thinking of your reasons, that's what you have to come back to. Those are the things you have to think about. Okay, so take 30 seconds, copy down this chart. There are 1, 2, 3, 4, 5, 6 slots.
Where's my brain? Nothing. Can I do the first one again?
No, I'm going to let someone else do the first one for a change.
Can I at least do the statement?
Okay, fine.
Yay.
Jalen, go get water really quick. really quick because I know you're home. You can go and come back real quick. All right. So here's my whole situation. I know that it's actually giving me kind of a lot of things. Okay. So let's start thinking about what we're trying to look for. So every time you get a problem like this, I always like to highlight what it is I'm trying to prove. So I'm trying to prove that ABF, so where's that? This triangle over here is congruent to this triangle over here. That's my end goal. That's what I'm trying to prove at the end of the day. And I'm going to get there using definitions, postulates, and theorems. So let's fill in what we know, and let's fill in what we're going to find out. So what goes in the very first box?
Given triangle BFC is congruent to angle EFC, which is and angle BCF is congruent to angle EFC.
Okay, so we've got this like very long thing from the very top part over here. So angle BFC is congruent to angle ECF. Angle BCF is congruent to angle EFC. Okay, now before I continue, I'm going to highlight those statements in my diagram so that I can visualize it. So I have BFC, that's this one right here, is congruent to ECF, which is this one right here. And then I know BCF, which is this one right there, is congruent to EFC, which is over here. All right, so take a look. What type of angles are those? What is that kind of, does that remind anyone of anything?
It's acute angles.
So those are, yeah, they're acute angles. We know something about triangle BFC and something about triangle EFC. We know two angles between them are congruent. What am I missing to prove that the whole triangle is congruent?
The other angle?
So I have I have two angles. What else do I need?
Side.
I need a side, right? If I'm trying to use ASA, I need a side. So which side is congruent between those two triangles?
EC.
EC?
Wait, FC?
EC or FC?
FC.
FC. And how do I know that
Reflexive property.
Reflexive property. So guess what, Tyrone? You just gave us the next step.
A.
So I know that F, can anyone give me the whole statement though? I know this is reflexive property, but what's the statement?
Line segment FC is, I forgot the rest.
Line segment FC is congruent to line segment CF.
Mm-hmm. Exactly. That's my reflexive property. Let me write that in black.
Oh, look. The balloon noodle.
Okay. So I've used reflexive. Now what can I say about those two triangles?
They're congruent.
Good. And what theorem am I using for that?
ASA.
Good.
SAS.
So I know triangle FBC. Who can finish that statement?
Is congruent to triangle CEF.
Yeah. F. Nice job. Okay. And sorry, what was the theorem that I'm using here?
The ASA.
ASA. There you go. ASA because I have a side, or sorry, I have an angle,
Side and an angle.
side, and an angle. So it's ASA. Okay, so now I know that these two triangles are congruent to each other, which can help us out, but there's one more statement that they give us in the original problem.
Line segment AB is congruent to line segment DE, and line segment AF is congruent to line segment DC.
Good. And I haven't used that yet, so now would be a good time to use it.
Is it
So
given?
I'm gonna highlight. Yeah, that would be given. So AB, where is that? That's over here, is congruent to DE. Ooh, that was crooked. There we go. And then AF is congruent to
DC.
DC, right here. Okay. And I'm trying to prove that those triangles are congruent. Matter of fact, I haven't written it down yet, so let me write down my final statement, which they give us right here. It's what we're trying to prove.
A triangle ABF is congruent to triangle DEC.
Okay. And if I'm trying to prove that, what is the missing part of the puzzle?
The proof.
Yeah, but what's the missing part of the puzzle? Without looking at the proof, if I'm trying to prove that those two triangles are congruent, what do I still need in order to prove that?
BF and CE.
BF and CE. So I need to prove to you that BF is congruent to CE.
Oh, miss, I know why they only put like the 1 and the 3 tick mark.
Why?
Because of like each side, you know, they were saying side 1 is congruent, side
And the
2
other
is not congruent, let's say, and then side 2.
Oh, yeah, in that example. That's true. Okay. But here, okay, so I'm trying to show, I need to prove that BF is congruent to CE. So that needs to be the next part of my proof, because I still need to prove that in order to finally say that both triangles are congruent. So that's step 5. So BF is congruent to CE or EC. But I need a reason. So let me go back. Let me actually put back all of the previous markings that I had. So I'm going to keep everything color-coded. So I know this is congruent. I know these two are congruent. And I know, what color haven't I used? I've used almost everything.
Black.
Okay. So that's everything I know so far. So how could I prove that BF and EC are congruent to each other?
CPCTC.
Good job. Yes, nice job. CPCTC, because I already know that triangle BCF is congruent to triangle CEF. So because I know that, and BF and EC are part of that, I know that I can use CPCTC. That's like Emily's favorite one, CPCTC. All right, so now I'm at the last final step. And now that I've shown you that all three sides of these two triangles are congruent, which theorem is this for my final step?
Proven or?
Proven is not going to be a reason.
Would it be?
What theorem can I now use between these two triangles?
SAS?
Not SAS.
Oh, SSS.
SSS, yeah. Okay. So we've got kind of a lot, but you guys did a lot better on this one than you did on the previous one. So it kind of gets easier and easier as you pick up on these patterns. And what we're going to be doing a lot of next week. So next week is kind of going to be dedicated to proofs, because we're going to, after we learn the last 2 theorems, we're just going to do proofs until this becomes second nature.
Miss Lopez, I just want to let you know from this week that I'm going to be sick all of next week. So I'm able to attend class, so I hope you understand.
Okay, you better give me a doctor's note.
I love math, you know me, I love math. But next week, I'm going to be sick the whole week, so I can't come to class.
Okay, those are big fat lies, Miss Santos. Okay.
Oh, it's Plantos.
All right, homework is already up, I believe, on Khan Academy, and it is due on Thursday at midnight. So it should be there already. Thursday at midnight, get it done. I'll see you guys tomorrow.
Bye, man.
Bye, everyone.
Did I do good?
You did really well today. Everyone did pretty well today, guys. I'm very proud. Good
Yay.
job.
Bye, man.
Bye.